of a chapter or part of a chapter. Now, this book is a pretty huge book, and every single chapter has lots of equations and content to discuss. So, we need someone to facilitate that every week because everyone is going to read a chapter before a meeting every week. It doesn't really matter who facilitates, but for learning the material really well and explaining it to others, it is a good practice for you to lead a chapter as a volunteer. So if I open the book here and let's look at the table of contents. So we have three main parts. It probably is not too big for you, but the three parts that we have in the book are traffic data, traffic flow modeling, and applications of traffic flow theory. There are lots of chapters and also practice problems that we need to look at. So I have divided these chapters into several sections. So we are probably not going to cover everything in a chapter in 1 week. We would do that if we have smaller content for a chapter. For example, for the first chapter, introduction, it is pretty small and we'll cover it today. But other than that, most of the chapters are going to be divided into several sections. So I have put all of that in the traffic flow dynamics um, sheet. I don't know what happened here. Let me refresh this. Okay. So hopefully you can see it. If you don't, please let me know. So here you see introduction and the second chapter, basic quantities of traffic flow plus related problems will be presented by me. So this is today. We are going to cover introduction. Next week, we are going to look at the second chapter. And then from onwards, we are going to look at each chapter and part of it actually in its own week. So we have trajectory data and the problems for trajectory data in the following weeks. Similarly, we have floating car data, part one, part two, and then the problems for the floating car data chapter. So I've divided it in this way because I am pretty sure that the content is a lot, and so we need to divide it so that it is easily readable in a week prior to the meetings. For the presentations, you see this slide deck at my screen, but you don't necessarily need to create a presentation if you are volunteering to present a chapter. You can just take your notes, or you can just show the book and just point to the different sections you are facilitating the discussions for. Our main focus is to discuss things and ask questions to each other if there are any questions that need to be discussed in detail. So there's no fixed format. If you want to create slides, that is great. If not, then it is perfectly fine. The main thing is that we want to review the material together and we need to discuss questions. And if there's any live demo, any simulation that we need to run using MovSim or Sumo, that's what we are going to mainly discuss, how that is set up, what are the assumptions, what are the constraints, and what are the results that we are getting out of those. And I talked about it a bit before. The pace for each week is to have one or part of one chapter per week, and it's split to multiple sections as I've shown you. And it is okay to combine shorter chapters, but I don't think there are short chapters after these first two chapters. And then we are going to meet every week except holidays. So I've tried to be inclusive in this schedule. It's not yet complete, by the way. I have gone until chapter 14, but there are others that I am still looking at the content and then dividing them accordingly. So we are going to meet every week other than holidays. If there is a particular holiday where you cannot attend, please let us know in the Bumble channel. And we will meet even if the presenter is not going to be available. So if for some reason the presenter is not available, we will still meet, we will still discuss. And Bumble is a good place for any offline discussion, any content that you want to share. So here is Bumble where you are already. And in the channel, we can share any related content. I have pinned some of that at the top. So the book website, the course that was taught by one of the authors, and their lecture recordings are also up. So you can refer to that if needed. So let's do some introductions. So if you feel comfortable sharing, please share who are you, your name, where you're calling from, if you are comfortable sharing that. And have you used any micro simulation or macro simulation software like Sumo, PTVSim, and others? And have you studied traffic flow theory before in your undergrads or grad studies? And what are you most looking forward to during the club? So I'll start. My name is Umair Durrani. I am currently a data scientist at the Prasad Group here in Ontario, in Canada. And I have used PDVism before. I am now using Sumo more. And I have studied traffic flow theory, but not in a course. I've studied it on my own during my grad studies. And the most I am looking forward to in the this club is to obviously read the chapters, but also to replicate some of the figures from the book and try to run simulations and understand the models as clearly as we can. So let's see here. Going to okay. I saw a hand up. Please go ahead.
Yeah, can you all hear me?
Yeah.
Yeah, hello everyone. My name is Ahsan Hamid. I am a doctoral researcher and I'm based in Loughborough University, UK. And my research is focused on uh, microscopic simulations of mixed traffics. I have experience of using Sumo. I have used Sumo before in my PhD. I have integrated some external models with Sumo. So uh, that is the level of understanding I currently have. And regarding my expectations from this course, uh, I basically want to get an in-depth understanding of traffic flow theory, different car following models, and the application of traffic flow theory. And by the way, I don't have a before my PhD degree, I don't have any prior exposure to traffic flow theory. So I'm also learning and developing.
Okay, great. Thank you so much for joining the book club. Sorry for not reading your chat messages before. Jitsi is also new for me, and I'm trying this because it is open source and we don't have any limitations to how long we can have the meeting. Generally, we'll keep it to 1 hour, but just to be safe, I wanted something that can accommodate us without any extra cost. So I did not see your messages before. I'm sorry. I'm gonna try sharing my screen again and let me know if you don't see it. So do you see it now?
Yeah, yeah, it is visible now.
Okay, great. Okay, so let's hear from others, and then I'll show you the previous slides again. So who wants to go next? Rasif, yes, please go ahead.
Sure. Hello, everyone. This is Rasib. I am based in Northern Virginia, and I work for a consulting firm as a traffic ops engineer. I've been working for some time, and most of my days start with simulation and end with simulation. So I, even though I have a master's, but I never really studied traffic flow theory or both in my undergrad or grad. So I really want to study it a bit and learn about it. So I'm pretty new in this area. So that's what I'm looking forward to from this book club. Thanks for the initiative. Also, I have used PTV Vism for most of my work, maybe a bit of SimTraffic, but SimTraffic is probably not like a prominent software. But I don't have any idea about Sumo or any of the other software. So that's also something I'm looking forward to picking up from the book club. So
Okay,
thank you.
great.
Look forward
You're
to.
welcome. And the yes, Sabah.
Well, first of all, I'm calling from Ontario, Windsor, Ontario, and I used PTV Vision before in my masters, and uh, I studied a little bit traffic flow theory in my grad studies, and I'm looking forward to use some more with at this book club. Thank you.
Okay, great. Thank you. Um, let's see who else we have here. I saw one other member. I think for some reason they're not here anymore. Okay, anyways, let's switch to the slides. If you did not see this before, the slides that I've created here, these slides will be available on the GitHub repository. I'll share this link in the channel as well. And so currently there's nothing here. So everything will be here, and any content that we create, we'll put it here, and this will be publicly available. By the way, all the recordings of our meetings, this one is being recorded as well. So everything will be in the channel. It will not be shared publicly. And that is mostly because we are covering the book, which is copyrighted. It is not available as open source anywhere. So I don't think it's a good idea to share that publicly, but we'll share the content on this repository publicly. And yeah, I think other than that, we have mostly covered about the split for the chapters. And let me show this to you again. So here we have the traffic flow dynamics schedule sheet, and you can see there are different sections of the chapters that I have divided. And so please sign up for one or more of these. I have signed up for the first two and from chapter 12, but I'm thinking to take some of these as well. Even if there is no presenter, one of us has to be a presenter when we meet every week. So try to volunteer for one. That would be great. Okay. So any questions before we switch to the first chapter? Okay. I'm going to share my screen again. Okay, do you see my screen?
Yes, it is visible.
Yes.
Okay, great. Okay. Okay, so the introduction chapter has three main parts that I want to cover. And you can add anything that you think is relevant. So This figure 1.1, shows the full life cycle of traffic flow modeling. So within traffic flow modeling, we have the fundamentals of traffic flow on the left here. Let me actually increase the size. And the main goal in the book is to create uh, models of traffic flow, macroscopic as well as microscopic, that are based on mathematics. So there's no data-driven models covered here. There's no machine learning in this book. They mainly use mathematics to model traffic flow, either at the macroscopic level, considering the traffic as a liquid, a flow, or at microscopic level at the level of individual driver vehicle units. So we have mathematics, which is using the fundamentals of traffic flow and traffic data. And once we have all these three, they are combined to create models. And we also get some empirical facts from observations of traffic. And then we combine these models and empirical facts to create a traffic flow model. For each traffic flow model, we have other tasks to do as well. We can use it for prediction, but for better prediction, we also need calibration. We need to calibrate the models for the traffic, real world traffic. So, for example, the speed distribution, the acceleration distribution is realistic. It is similar to what we have seen in the field. Now, in the next section, in the delimitation of traffic flow dynamics, there's this table that shows you the scope of what the book is going to cover. So, in general, there is vehicle dynamics, traffic flow dynamics, and transportation planning, which are interrelated concepts and fields. Within vehicle dynamics, the time scale is less than zero point 0.1 seconds. That's why it's called as sub-microscopic, and it looks at the control. Control theory is in its own a complete field, which is about control of the engine and the brakes. The acceleration models and the braking models are covered within vehicle dynamics. On the other hand of this spectrum, there is transportation planning. Transportation planning goes from 1 hour to 50 years or more, and it looks at route assignment and traffic demand. So, traffic demand is about how many vehicles will be, for example, on a highway, where we also look at the concept of the capacity of a highway. And it looks at the aspect like peak hours, daily demand pattern, and how much infrastructure is needed to incorporate the traffic demand. Based on that, we assign routes. So if you have looked at or heard about the four-step modeling before, one of these steps is the route assignment. What routes would people take going from one origin to a destination? So transportation planning is about that, and it's also about using socioeconomic structure, demographic change, and looking at the growth of the traffic in several years in the future, and how we can incorporate uh, the traffic demand in our current infrastructure and how we can do it in the future. Any comments, questions about this section?
So the time scale means is it the same thing as time step, like how the model and the software is reading the vehicles?
I think there is a difference. In some cases, yes, time scale will be the time step as well, but not necessarily. For example, within traffic flow dynamics, which is the main scope of this book, it shows here that it goes from 1 second to 10 minutes. But if you look at microscopic models, you've used PDVism, we mentioned before, it uses, for example, a time step of zero point 0.1 seconds,
Right, right.
which is not mentioned here. So it could be time step, or it could be just what is the range of that prediction. So what will be the eventual result, and what is the time range for that? So it could be a time range, as I understand, or it could be the time step as well.
Okay, thanks.
Okay. And other than that, there's also this discussion of agent-based dynamic traffic assignment. So dynamic traffic assignment is part of the transportation planning, and microscopic traffic simulation models is part of traffic dynamics, which is what the book is going to cover. But agent-based dynamic traffic assignment is a combination of these two types of models that can look at the microscopic movement of agents that could include vehicles or people. And it also considers the dynamic traffic assignment, where people are going, origin and destination, and what routes they are taking, what modes they are taking. This is obviously a much more complicated model than just using a microscopic simulation uh, model. And some of the applications that are related to traffic flow dynamics is generation of surrounding traffic in driving simulators. If you have used driving simulators before, or if you've seen it, they are used to generate different traffic scenarios that are not easy to generate in real world. And for collecting research data using driving simulators, you require to create surrounding traffic. And with traffic flow dynamics, if you understand the models well, you can generate that realistic surrounding traffic. You can also create model-based online traffic state recognition and short-term prediction as input for traffic information channels. So traffic information channels is where through radio or through websites, you provide information to public about what is happening. For example, an incident is happening, congestion is happening. So all of that is possible using traffic state recognition, which could be model based or using other approaches. And traffic flow dynamics is great to facilitate that. You can also determine the optimal routes in connected navigation systems. So this also uses traffic flow dynamics, planning and optimizing the logic of external traffic control, such as variable message signs or ramp metering. So if there is variable message signs, that is possibly going to control the speed limits, for example. So it's going to change speed limits over time. And so if we understand the traffic flow models better, we can create variable message signs at different hours of the day accordingly. If we obviously don't have that background knowledge, then this is not possible. Otherwise, our predicted speeds, that the speed limits that we use, that could have a very detrimental effect on the traffic itself. Any other points here in this list if you want to discuss? So I'll briefly just cover two more. So another advantage of learning about traffic flow dynamics is that we can optimize the logic behind the operation of traffic lights. So if we want to create, for example, green traffic waves between different intersections, then obviously we need to understand the traffic flow models first. And then another application is within ITS, and these days it is very hot. Advanced driver assistance systems and L5, L4 level driver assistance systems are using obviously traffic flow dynamics knowledge to create them and see what will be the effect on the traffic. So other than that, at the end here, they mention MobSim and an open source simulator. So let's take a look at that. So here's MobSim, and as I mentioned before, it is a Java-based application. And the way it works is that you need to install a few things. We are not going to do that today, but we'll do it whenever we need MoveSim in whatever chapter. But the way it would work is that we need to first clone this repository and install Java. Also install Apache Maven. This is what is going to build this particular software, MoveSim. And this GNU plot is used for creating plots. So I've tried it for one small simulation and it works well. So we'll discuss this when the time is right. But these are the three main things that you need to do. You need to first install Java, you need to clone this repository, and you also need to install Apache Maven, and then this will work. Uh, Very subjectively, this software is not user friendly at all. It uses Java code, and I'm not familiar with the Java programming language. So I just followed exactly what the sim scenario folder says here. So within the sim folder, there's this scenario about start and stop, and it has different models that it uses. So if I go to, for example, start stop GIPS, this is using the GIPS micro simulation software, and it has set up everything, all the parameters of the GIPS model. And then I just ran this file using the Java command, and it worked. It showed me a GUI, it showed me simulation running, but I did not understand a lot of how this is set up other than the GIPS model parameters. So that's why I'm thinking to use Sumo to replicate this and also use just numeric simulation, just using the equations directly in Python to get to the same results. So that is one of the efforts that we are going to do in this book club. Okay, and the other one, which was mentioned in the book chapter, is this one, traffic-simulation.de. And this is using the intelligent driver model for a car following model and the mobile lane changing model. But it has the advantage of using different types of scenarios. So for example, here we have another scenario, and then there's also a roundabout scenario, and you can change the traffic settings here, traffic inflow, time lapse, and then here is the car following behavior, which is using the IDM parameters.
Are you showing something on the screen? I'm seeing only the book.
Oh, let me stop sharing and reshare. Sorry about that.
No worries.
Okay, do you see it now?
Yeah, we can see now.
Okay, great. Yeah, so traffic-simulation.de is another one of the software that is shared in this book. And they sometimes refer to it in some chapters. Mostly they use MoveSim, but this is another one where you can see live how changing some of the model parameters changes the traffic. So here, car following behavior is controlled using the intelligent driver model, which is one of the models that the authors have created, I think, back in uh, early 2000s. And since then, there have been many different applications in adaptive cruise control for human drivers. There are many different applications of IDM, which we'll be reading, I think, in chapter 12. So this is another software. The one that I was showing before is MoveSim. So MoveSim is on GitHub, and it has this folder sim, which has different book scenarios. So if I go to book scenario start stop, and if I go to, for example, book scenario for IDM, then here it has all the settings for IDM. Here you can see the model parameters of IDM, which obviously wouldn't make sense right now, but as we read chapter 12, this will be easy to understand. But personally, I find MovSim much more difficult to work with because it is not very user friendly. Anything that you have to do, you have to do it here in this file. Go change the parameter values. If you want to change anything about the geometry of the road, it has a separate file and you need to go there and change that. Compared to this, I find Visnim or Sumo easier. So we'll try to replicate this in Sumo and also numerically just by writing Python code. Okay, I think that covers everything for the first chapter. For the second chapter, basic quantities of traffic flow, we'll start its discussion next week. So I encourage everyone read this. I will be the presenter for the next one as well. And please sign up for any of the other chapters or part of the chapters listed in here. Any questions? Okay, great. So I'll see you next week. Please don't forget to read the chapter. Thank you everyone for joining.
Great. Thank you so much. Have a good one.